As we look at 67, I want to remind you of something, and I'm going to use Desmos to remind this for you. Negative sine of negative theta. So I put these in here. Here's negative sine of negative theta, and there it is. It's a normal sine wave, and then I just plug in a normal sine wave, and well, it's hard to see over the other one, isn't it? So there it is in green, and there it is in blue, and it's the same wave, okay? And I suppose I could also show you that this is an odd function, and odd functions, if we go through the origin, that's not very beautiful, but we see reflection through the origin. And I wish I could do better than that. Can I zoom in? Yeah, sure. Okay, so if I go through the origin, I should reach a point on the other side, okay? Wherever I pick, if I go through the origin and I go straight enough, I should get to a point on the other side that corresponds. This is not an even function. If you remember, a parabola would be an even function. I'll give you a quick demonstration if I can get my pen to come back here. A parabola goes, like this, and we have a point on this side and we have a point on this side. It's y-axis symmetry. This is not that. Let me undo that. So for the odd function, it does matter. It does matter that the angle is negative. For the even one, I guess I should have left that up there. But for the even one, it doesn't matter. I plug in, something better than that. I plug in, terrible graph on my part, sorry. I plug in 2. It doesn't seem to matter if I plug in negative 2. It's supposed to be that way anyway. Okay, so terrible demonstration, but you get the idea. Even functions, it doesn't matter. Odd functions, it does matter. Okay, so let me get out of here. Maybe you get the idea. Anyway, it made no difference because I had 2 negatives. So let me go back to this. So I could just as well write, and this is important to what I'm doing, I can write the cosine of theta is equal to sine of theta. It does matter, so I take, and by the way, cosine is the other way. If you look at a cosine wave, you will see the same thing, and it's a reflection across the y-axis, just like a parabola, just like an even function. Okay, sine and tangent are odd. It matters what you plug in there as far as the sine. It will change things. If you had cosine of, of negative theta, you'd be like, well, that doesn't matter. I can just say this, because it's true. It's the same thing. It doesn't matter what you plug in. It matters for sine, okay? So I have a negative in here. It takes away the negative out here. All right. So now let's see. How can we go about fixing this? Well, there's a couple ways. I thought just to be different, I'd do this. And I'm going to, let me square this. I know when I square it, I could be introducing superfluous things, extraneous things. But when I square it, I get cosine squared theta minus 2. So I'm going to put the sine first. I can't help myself. And this equals 0. And you say, I don't know how this really helps me. But anyway, maybe it does, because you can see that this part and this part, you remember the Pythagorean identity? Okay, so that's gone. Yeah, well, it's 1. It's 1. I don't want to say it's gone. So I have 1 minus 2 sine theta cosine theta. And my trig identity says, hey, I also recognize this as a trig identity. And I can say, 1 minus the sine of 2 theta. Okay? And that equals 0. So I guess the question comes in, when is the sine of 2 theta equal to 1? Because then it would be 0. And now I think to myself, well, when is the sine of, let's just say the sine of x, when is the sine of x equal to 1? And I'd say, well, that happens at pi over 2. Okay, so I need something that when I multiply by 2 gets me, gets me that. Okay, so any other time? No, I think that's the only time. So I divide by, oh, I don't want to do it that way. I'd rather do it this way. Makes it more clear. Okay, so what that tells me is if I say the sine of 2 times pi over 4, okay, that gets me 1. Is that true? Well, the 2 cancels with the 4, and I get the sine of pi over 2, and that is equal to 1. And I say, okay, that's great. And then it's bound to repeat itself a little bit. Let's go over there and let's see what our graph says, and we'll try to wrap our minds around it based on what the graph says. So I'm just going to go ahead and type in that. Shouldn't box that, I guess. But anyway, cosine minus sine theta. And there it is. Okay, I'll get rid of these guys. And you see right here, that is a point there, and there's a point, and that's too much. I was supposed to stop. Okay, so it happens again because we've shortened it. Let's go back. We're going twice as fast, the short answer. We're going twice as fast, so what's the period? The period is 2 pi over b. Is that right? And b is 2, so therefore my period is pi. So it's going to happen twice as much as we might have thought. And so our answers are x is equal to pi over 4 and 5 pi over 4. And that'll be great. And it does work out anyway. Let's see, if we plug in the sine of 2 times 5 pi over 4, we're going to get, well, it just comes back around. That's kind of silly, isn't it? But had to take that into account. So 5 pi over 2, it works. So this is around once, and then it's right back to where we were before. So, okay. Anyway, those are our answers. Both those answers work, and they're between 0 and 2 pi, including 0. Okay. So that all checks out, and it didn't bite me to square things. And I know I could have done it differently, but that's how I chose to approach it. Feel free to experiment.